Jacon, this is my assignment 1 code review. So this is my node class, and here we're overriding the less than methods and the greater than methods to compare the nodes for the priority queue. We have a child function that returns a successor based on the new position of the successor. Then here's a successor function. We have a dictionary called possible moves of the key is the index on the array, and the dictionary returns a list of possible moves that can be made by the blank tile from every index. So I'm going to loop through all the possible moves and create new children using the child function. And we're going to add this to the children's list, and we're going to return the list. So that's our successor function. So here the first search algorithm is the depth first search. And just to note, all the search algorithm or search algorithm classes are subclasses of the search class. So we're going to use a queue, and we're going to add the first states to the queue. And for state checking, we're using a set called visited, and we're going to add string representations of our array because strings are hashable. So we're going to use a set for that. So we add the first node, then we're going to loop while the queue isn't empty. So after we start the loop, we're going to pop from the back of the queue since this is DFS. So it's last in, first out. Then after we pop from the queue, we're going to do the go test. If the go test fails, we'll call the successor function. We're going to loop through all the children. Then we're going to do the state checking here. So we're going to check if the state is in the visited set. If it's not, we're going to add the new child to the queue, and we're going to add the state to visited. And we're going to do this till the go test is positive, or if it fails, it returns a negative. For the breadth-first search, is similar, just that we're going to pop left. So we're going to remove from the front since it's first in, first out. And another difference is that the go test is done in the inception of the child or the successor when it's created, instead of after we pop it out of the queue. For uniform cost search, we're using a priority queue, and the priority queue is going to compare the nodes based on the F value. So in the uniform cost search, the cost is going to be based on the cost of moving from the start node to the current node, and this is how we calculate it. So we're going to get the cost of the tile that was just moved and the cost of the parent node. And another thing is that unlike the BFS, the go test is done as soon as the node is popped from the priority queue. The same thing, it's similar with the best first search, just that we're going to use a heuristic instead, which is the misplaced tiles heuristic. So the same thing, the state checking, the same, the go test here, we're going to loop through the priority queue while it's not empty. So that's how our loop is. For the A-star search, the difference would be in our constructor. We're going to have a callable, which will either be the Manhattan function or the misplaced tile function. And you can see here, we're going to loop through the priority queue, and we're going to pop it off, do the go test, call the success function. We're going to loop through that, and you can see here the difference is the cost is going to be based on the cost of getting from the start node to the current node, and also the heuristic value. And remember, I said we have two heuristic values, so it depends on which one the user chooses. And we're going to calculate the F, and we're going to set out the cost, do the state checking. So that's a brief overview of the code, and we have some utility functions here, such as the misplaced tiles, the Manhattan function, and the printing whatever. So let me just run my code, show you how it works. So I'm going to run our code. The program gives you options. You insert your options. You do that. This is the output. So that was for BFS or DFS. I'm not sure. Yeah, that was for BFS. This is for DFS. You can set the difficulty. You can see it is working. Then we can do this for, let me do this for the A star search with the H2 heuristic. Then yeah, it's taking some time. And you can see it's printing the go path and also some different details, and that should be all for the code.